Hello, in this lesson, we're going to talk about solving exponential or logarithm inequalities. Okay. Regarding solving inequalities, we have done those inequalities before in the quadratic form. A lot of the basic ideas are actually very similar, but it's just, of course, for different rules of function. So I'm going to explain this to you with the examples. The first one, okay, so we're going to say solve for x, right? And the inequality involved is ln x less than 0, okay? So the perspective is as follows. Right, the perspective is as follows. First of all, of course, this is a rule. The rule of this function is ln x, and the meaning, right, is the input is to be found. We don't know the input, but we want the output to be. We want the output to be negative. Okay, so the output, we want it to be negative. That's what the question is all about. So we know the output, but we don't know the input. Okay. So if the output is negative, right? If you look at the picture, right? If you look at the picture of ln x, when will the output be negative? Right? So that becomes very obvious. So here I'm gonna just to have a picture. And over here, we got the curve. Right? So this is ln x. So the output, we know that the output is the vertical, right? Measured from origin, right? The vertical. So what are the output? The outputs are, these are input, and that's the output, right? That output is positive. And this is the input, right? And that's the output. The output is negative beneath x-axis. So from this picture, the solution is pretty obvious, right? But we also have to consider that the domain of this function, right? The domain of this function is whatever the input, that input has to be positive, right? So the solution are really just from 0 to 1, okay? These inputs, so the solution, the output will all be negative, right? So from the picture, you can see the solution is rather obvious. It's rather obvious, okay? So let me just graph these pictures and how we do it algebraically. The algebraic perspective in this question is also pretty straightforward, right? So I'm going to show you in a moment. So this is, I'm going to put a circle here, right? So that means the point is not included. Okay, the point is not included. And there's also a bunch of input, right? We have lots of solutions, that those solutions are going to be between 0 to 1. So that's our solution. And these input, their respective outputs, okay, let me use a different color. Okay, so those output are negative. So these are the negative outputs. Okay, these are the negative outputs. And so it can be as small as possible, It will have infinite number of solutions. Okay. All right, so from the function perspective, from the graph, it's pretty easy to tell the solution. Then how about algebraically? Well, algebraically, I would give you an algebraic perspective, right? So now let's finish with this, the graph. The solution would be from 0 to 1 exclusive. Algebraically, algebraically. You can do it this way, right? 0 is equals to ln 1, right? And ln x is an increasing function. Ln x is an increasing function. Ln x is an increasing function. So when the output, right? So the output ln x is less than ln 1, and therefore x is less than 1. X is less than 1, okay? And that's it. But we also have to take into consideration, okay, domain, okay? So domain of ln x is x is larger than 0. X is larger than 0. So less than 1, algebraically, domain. So finally, we get the solution. So combine these information. So algebraically, we can do it. That's the solution. Okay, but you have to consider the domain right here, right? Right here. So you can do it algebraically, but you need to be aware of what you're doing. You need to be aware of what you're doing. Okay, so that was the first question. Okay, the second question, example number 2, is that we're also solving for x, right? But this one is an exponential function. Okay, so we have e to the power x larger than 5. Domain-wise, e to the power x has a domain of all real numbers. Okay, so we want e to the power x to be larger than 5. In other words, if you look at e to the power x as a function, right, and this function takes input, which can be any real number, right, the rule of the function is the input will be used to power e, produces output, and we want the output to be larger than 5. Output is larger than 5. That's what it means. Okay, larger than 5. And what does that mean? Right? We graph the picture. If you look at from the function perspective, right? The picture, this is the picture, e to the power x, and you can just sketch it. You can just sketch it, right? It doesn't have to be precise. It doesn't have to be precise. And right here. So that's the e to the power x. That's the curve. Larger than 5. We want the output to be larger than 5. So you're going to draw a horizontal line. You're going to draw a horizontal line, which is a 5. We're going to draw a broken line. Why broken line? Because it doesn't equal, right? So this height is y equals to 5, because we want the output to be larger than 5. So we draw the line larger than 5, right? Larger than 5. So hold on. I'm going to mark this line. Okay, that line is y equals to 5. And I'm going to put it at, put at a place that's obvious. Okay, for us to see y equals to 5. There, so y equals to 5. This horizontal line is y equals to 5. So what do we want? We want the output to be larger than 5. So what are the inputs such that the output is larger than 5? Well, for this input, the output is smaller than 5 because it's beneath 5, right? And this input is larger than 5. Okay, and what is the point that separate these? Larger than 5 or smaller than 5? This point. This point, right? So we need to identify this point. We need to identify that inputs such that the output is 5. And beyond that, right? Beyond that, we get the points. We get all these solutions. So what are all the solutions? The solutions will be from here. All of these inputs. Wait. Let me redo this. Okay. So all of these input beyond this input, right? This input right here. So what that point should be? So what should be that point, right? So you need to find that point, which is equals to 5, right? So you're going to set e to the power x. Wait. E to the power x equals to 5, right? As a result, x equals to ln 5. Okay, so this point is ln 5, comma 5. That there's a red circle. Okay, and beyond that, the solution, which are the inputs, will make the output to be larger than 5. So this point, okay, when x is equal to, okay, so when x is equal to ln 5, the output is exactly 5, right? So we're gonna put that over here just to show you the point, right? So this point, right, I can make it even closer. Let me make it just a little bit closer. Okay, would this be better? Okay, yeah, this is better. So this point is e to the power x equals to 5, but we don't want it equal to 5. We want it to be larger than 5. So what are those input? So all the input that's larger than ln 5, right? So we're going to mark that ln 5 on the picture on the x-axis to indicate the inputs, which is going to be a circle. So that point is not included, but everything after, okay, everything after. So you have ln 5, 0, and now all of these numbers, okay, all of these numbers whose output, okay, whose outputs will all be larger than 5. Does that make sense? Okay, so you can see all of these input, right? Output. And all of these output are higher than 5. So that's what it means. That's a geometric meaning. That's a geometric meaning. Okay, so we can use this function to tell us, and so you can use these functions and tell us input output, right? We want the input to be positive. Algebraically, what can we do? Algebraically, you can do the following, right? You still see it, view it as the input output, right? But E5 is equals to what? Is e to the power of what? ln 5, right? E to the power x is an increasing function. Increasing function means when the output e to the power x is larger than the other one. So let me write down the increasing function definition. The increasing function definition basically say, well, f of x sub 1 less, sub 1 less than f of x sub 2, right? If this is true for increasing function, it basically means that x1, x sub 1 is less than x sub 2. Okay, so this is e to the power. These two are outputs. Okay, so e to the power x is larger than. For input x, the output is e to the power x. For input ln 5, right? So let me put it this way. Okay, if this is true, right? Output, input are x and ln 5. Therefore, according to definition, x is going to be larger than ln 5. Increasing function is used. So algebraically, we can also do this. Okay. All right, so let's look at the third example. Okay, example number 3. Okay, and of course we're solving for x. Solve for x. Solve for x, but this one is e to the power of 3x minus 2. Minus 2. And we want this to be between 1 and 2. 1 less than that and less than 2. And there we go. I'm making the fonts just a little bit larger. So that's the question. So in between, we want it to be in between. Okay. If you look at the function perspective, you can just graph this function, right? Graphing this function, you graph it, right? So this is a curve. We know the domain is all real numbers, right? So we're making some adjustment between, so we can have a nice frame. It's going to be positive, right? The whole thing is going to be positive. And that's the curve, right? And the curve, I think I need to make a little more adjustment here. Something like that. Well, maybe we don't need to be that high, this way, right? And the right side is, we can make it narrower, right? So that's the curve. That's the curve. And there we go. Between 1 and 2, the output is between 1 and 2. Okay, what does it mean between 1 and 2? It's between, in between. Okay, so you're going to draw horizontal line y equals to 1 and y equals to 2, horizontal line. Okay, so I'm going to draw horizontal line 1, broken line, horizontal line 2, broken line. So in between, there's these 2 points, right? This is y equals 2, this is y equals 1. So let me mark it. Okay, I want you guys to really understand this. So y equals to 1. We're going to put it at negative 0.5, 0.75. So this should do the job. Okay, so that's y equals to 1, and this one is y equals to 2. For y equals to 1, I want it to be scooted over just a little bit. Okay, and y equals to 2, all right, so the 2 lines are drawn. Y equals to 2, y equals to 1. Between these, the output are between 1 and 2. And so we want the input. Okay, we want the input which is in between, right? So there's a point here, there's a point here. This one has an input, and that one has an input. So the input we want is just in between. Okay, just this much, just a little bit. Okay, so that's what we want. That's what we want. Okay, so how do we determine the point? How do we determine the point, right? So you're going to figure out when e to the power 3x minus 2 is equals to 1 precisely. Okay, so we're going to determine this point precisely. So we're going to set this piece, equals to 1. What would that be equal to? Right? What would that be? Well, 1 is equals to e to the power 0. E to the power 0. And therefore, because e to the power x is a one-to-one function, so 3x minus 2 is equal to 0. Okay, so as a result, 2x equals to 3x equals to 2, then x equals to 2 over 3, 2 over 3. So x equals to 2 over 3. What does that tell us? When the input is 2 over 3, right, the output is 1. So that marks this point, okay? So this point, 2 over 3, and the output is 1. Okay, so we're going to put that point as a circle because it does not equal. So wait. I think I forgot to mark. Oh, make it red. Wait a second. Okay, that's, 11. My bad. E1. Okay, so right there. So this point is when x equals to 2/3. Okay, 2/3. So this is 2/3. Okay, and the vertical is 1. Okay, let me show you. This is 2/3. Okay, this is 2/3. And this height is 1. Okay, so over here is 2/3. Over here, the green is 1. Okay, so we find this point. So the input is from 2/3, larger than 2/3 to the next point, okay? And to find the next point, we're gonna set e to the power 3x minus 2 equals to 2. Okay, we set that equals to 2. We set it equals to 2 to identify that point, Okay, I'll show you the algebraic way to do it, okay? But here, what we have is we want to solve for x, right? So what we can do is that we take logarithm on both sides. Okay, we're going to take natural logarithm on both sides. And we can because both are positive. Okay, on the left-hand side, we have 3x minus 2. On the right-hand side is ln 2. Adding 2 on both sides, you get 3x equals to 2 plus ln 2. And divide both sides by 3. So x equals to 1/3 of 2 plus ln 2. So this number, okay, is going to be the input for this point. Okay, so that point is now determined. Okay, the output is 2. And of course, you're going to have a circle dot. So these 2 points are determined. And what's in between? In between is the input we're looking for. In between are the inputs we're looking for. Okay. So now I'm going to take the picture and mark the point so you can see well. Okay, so you can see. Okay, I want you to see these points. Now, the first point, which is here, and that's 2/3, comma 1. This next point is this point. The output is 2. Okay, so these are the 2 points. These are the 2 points. And so let me mark them for you. And so this point is right here, and that the other point is right here. And the input, okay, this is the input, 2/3, and the other one is the other input. Okay, so so the input is in between these two. So I'm gonna show you those numbers on the picture. Okay, so these are the numbers in between, right? So 2/3. And over here, okay, so that piece, which is going to be red, thick, and there's 2 circles. There are 2 circles. Two circles. Two circles. So this little piece, this is the little piece. In this little piece, right, between 2/3 and 1/3, 2 plus log base 2 and ln 2, the output, right? The output, any input, right? The output is between 1 and 2. Okay, so for that input, the output is between 1 and 2, larger than 1, smaller than 2. Okay, so that's the geometric meaning. That's a geometric meaning. Okay, you can see we draw a horizontal line, identify because we know the output is between 1 and 2, and we're just looking for the inputs. Okay, so this is the illustration. This is illustration. Now, algebraically, how do we do it? Right? Algebraically, how do we do it? How do we do it algebraically? And this is how you do it, okay? Algebraically, okay? Algebraically, because E function is an increasing function. Okay, this is very important because it is an increasing function. So when we take ln 1, when we take ln on all sides, ln is also an increasing function. And so this is going to be true. The reason is, okay, the reason is ln x is an increasing function. Ln x is an increasing function. If it's a decreasing function, we have to reverse the directions of the inequality sign. Okay. If it's decreasing, we have to reverse it, reverse the inequality sign. Okay. So fortunately, we have these. Okay, so we take a logarithm on both sides, and ln 1 is equal to 0, less than. On here, we have 3x minus 2. 3x minus 2 less than ln 2. And we're going further, we're going to add a 2 on every side. So we have 2 less than 3x and less than 2 plus ln 2. Okay. All right. And divide every side by 3. Divide every side by 3. 3 is a positive, so we don't need to change anything. Okay, so this divide by 3. And this divide by 3. and it's just going to be x left, and this one divided by 3. Okay, divide by 3 is multiplied by 1/3. So you see, we get the same answer. We get the same answer. I would say you should, for your best interest, you should understand both. Okay, this is analytical geometry. This is how you understand analytical geometry. If you understand both, you will be really, really, you will really benefit from this process. Okay, you will benefit from this process. So we have some of other examples here, right? So see number 5, number 6 are similar questions, right? And let's look at number 4. Let's look at number 4. Okay, example number, and this will be our example number 4. Okay, question number 4, and this is from our homework, right? Still is solving for x. So the inequality is 1 minus 2 times ln x less than 3. Okay. Algebraically, right? It seems that we're gonna manipulate this algebraically. Okay. What you can do is that you're going to subtract 1 on both sides. Right, subtract 1 on both sides, you have negative 2 ln x less than 2, right? Because it's subtracted by 1, 3 minus 1 is 2. And then we're going to divide both sides by negative 2. When we divide both sides by negative 2, we're going to have to switch the directions of the inequality sign. So ln x is going to be larger than what? Larger than negative 1. Okay, so ln x is going to be larger than negative 1. So what will be the solution, right? So if you do it algebraically, and you're going to see, oh, what is negative 1, right? Negative 1 is ln e to the power of negative 1. Oops. Okay. So ln x is larger than negative 1. It's the same as ln x is larger than e to the power negative 1. Ln x is an increasing function. So this will lead us to what? This will lead us to x is larger than what? X is going to be larger than e to the power negative 1. Oops, sorry. E to the power negative 1. Okay. So that's, and of course you want to make sure you understand that reason. Okay, you need to understand that reason. Ln x is an increasing function. Okay, if it's a decreasing function, you have to switch the directions of the inequality sign. So you can see that in many cases, working this out algebraically is it's very easy. Okay, but it's also important to understand the function perspective. So by this time, you're done, you're finished, right? So let's look at the function perspective. Function perspective, right? And of course, you're gonna work on this piece, right? If everything is worked out correctly, you want to look at ln x greater than negative 1. If that's, you can see that way. Right, so this is ln x. We want it to be larger than negative 1, right? We want it to be larger than negative 1. So let's make some adjustment to the picture. And right, so over here, and that should be a reasonable picture, right? Larger than negative 1. We want this to be larger than negative 1. Okay, larger than negative 1. What are the larger than negative 1, right? So you're going to draw a horizontal line, y equals to negative 1. It cannot be equals to, right? So I'm going to draw a broken line. the output for ln x larger than -1 means what? That's -1, right? So all of these, okay, so these output are larger than -1, larger than -1. 0 is also larger than -1. So you can see all of these heights are larger than -1. So our solution would just be what? From here, there's a crossing, right? There's a little crossing. How do we find the crossing? Well, we set it equals to -1, right? So we set it equals to -1, we'll be able to find the crossing. To find the crossing, right, we're going to set ln x equals to -1, right? So the result would be x equals to e to the power of -1. Right, so we find the crossing, and that crossing is e to the power -1, right? Oops, e to the power -1, e to the power of -1, and the output is -1. So we put a little circle there, right? So the output, right, to be larger than -1, what are those inputs? The inputs is from e to the power -1, so all the way from e to the power 1, all the way to infinity. So we're going to mark the interval, okay, e to the power -1, 0. So all of these numbers, okay, until infinity would be the solution. And of course, we also need to mark that e to the power -1, comma 0, and that has to be a circle. That has to be a circle. There you go, right? So all the numbers larger than e to the power -1. Okay, so that point, okay, so let me show you the point. Let me show you the point. Okay, so there are 2 points here. We have 2 circles here, right? One point is e to the power of -1, comma 0, and the other point is e to the power -1, -1. So what are these 2 points? E to the power -1, 0 is this point. E to the power -1, comma -1 is this point. And these are inputs. Okay, output, input, input, output, input, output. And right here is this is to indicate all of these numbers larger than e to the power -1. Those output will be larger than -1. So this is the geometric meaning. This is geometric meaning. You can see all of these are consistent with what we learned before in the quadratic case, even in the trig function case, and in the, we will be talking about solving some trig inequalities, right? So it's very important that we have this function perspective. We have this function perspective. So let's work on another one. Okay. This should be example number 5. Example number 5. We have an interesting one. Okay. This one is, of course, solve for x. Right? And this one, it should look familiar to you. It's ln x squared less than or equal to ln x squared. Okay. We have talked about the difference in these notations and domain of functions and so on and so forth, right? And ln x, right? So we're going to put a note here, okay? Just to make sure we still understand that. This means ln x times x. And the other one means, okay, the other one means ln x times ln x. So they're very different. They're very different, okay? The order of operation goes like this. So x, we first make x squared. Okay, x squared will be the input of ln omega and produces output. And this one, however, x is the input, and we're going to get to the natural logarithm, so we get ln x, and then we take the ln x and we square it. So you see it's very different, okay? So that's how you get these differences. And we also talk about these two functions have different domain, right? This domain is all real numbers, but not a zero, right? And this other one has, x has to be 0. X has to be larger than 0. So with all that being reviewed, and we understand their notations are different. So how do we solve this inequality? Well, this is how we can solve this inequality. Excuse me. We're going to bring them to the same size. Okay, so what we're going to do is I'm going to take this piece, subtracting that piece. Okay, and that's going to be at least 0, greater than or equal to 0. So basically move this piece to the other side and make it larger than 0. So we're making 0. So making 0. Does that sound familiar to you? Make 0. Okay. And once we made 0, we're going to apply the power rule to ln x squared. So that's going to be minus 2 times ln x. And that's going to be greater than or equal to 0. Factor. Okay, factor. Factor, what do we get for factoring? We get ln x minus 2, and there's another ln x, right? Hold on, there's another ln x outside because we'll factor out the ln x, right? And this is going to be positive or 0, okay? Or you can put this on the side, okay? Put the ln x on this side to avoid any confusion. So we have this product. We have this product, okay? This question is a little bit, complicated. And then we're going to work on the sign. We're going to work on the sign change, right? We're going to work on the sign change. So what are the sign changes? When does ln x minus 2 change sign, right? When? So we're going to look at sign change. So in order to work out the sign change, we're going to first set them equal to 0. Okay, so we're going to set these two pieces, the product equals to 0. And this is something we have done before, right? We've done before. At the time we did a substitution, right? So we have ln x equal minus 2 equals to 0, or ln x, ln x equals to 0. And we get solutions, right? We get solutions. Here we get ln x equals to 2, and then x equals to e to the power of 2. On the other side, we just get x equals to 1, right? So we get 2 solutions. So these are the places that ln x changes sign. Okay, ln x changes sign. So regarding the sign change, look at that, right? Let's start with ln x. Ln x, sine of ln x. I also want to put the picture for you as a reference. Okay, ln x picture we're pretty familiar with, right? ln x picture is like that. Okay, where does it change sign? It changes sign at 1. Okay, it changes sign at 1. So let me make a little adjustment to the picture, which is over here. And this make it 4. Okay, I think that's a good enough a picture. So ln x, when does it change sign, right? The sign of ln x. Domain we understand, right? It's all positive. So, on the number line, where does it change sign? It changes sign at 1. Change sign at 1, right? You see, less than 1, between 0 and 1 is negative, right? So these output are negative, and these output are positive. And here is the output is 0, right? So there we go. We look at that picture so we can tell, right, at 1. So from here, ln x is what? Negative from 0 to 1, right? So I'm going to put a 0. From 0 to 1, not including 0, and at 1 is 0. Above 1 is going to be a bunch of positive. Okay, that's the sign of ln x, if that helps, right? How about ln x minus 2? We just discovered that ln x minus 2 changes sign too, right? Where does it change sign? E squared, right? So the sign of ln x minus 2. Ln x minus 2, right? Ln x is an increasing function. So where is that where is that e squared, right? Where is that e squared? E squared, we can find it, right? E squared is a point, right? E squared, we can plot that point. E squared, wait. E squared. There's a point. I'm going to make it a circle. Wait, that's e squared. See that? I should make it red so you can see clearly. Red. Okay, so that's 1, and that's e squared. That's e squared, right? E squared is right here. So I'm going to take this number line. I should make it a little longer, right? And these are positive. So now we're working on the sign of ln x minus 2. So after this, beyond this point, is going to be positive, less than, negative, and so on and so forth, right? So it's about the same number line. It's about the same number line. Except here is going to be e to the power of negative 2, e to the power 2. E to the power 2. Okay. On e to the power 2, when it equals to e to the power 2, then ln x minus 2 is going to be 0. Less than is going to be negative, right? So all of these are going to be negative. Sorry. So all of these are going to be negative for ln x minus 2. And at e to the power squared, that's going to be 0. above it, it's going to be positive. Okay. So this is a sign analysis. This is sign analysis. Does that make it? Let me make it just a little bit smaller. So let's look at the product. When we want the product to be positive or zero, right? So now we're going to look at the product. What is the sign of the product? Sign of the product, right? So I'm going to put this on the side. Okay, I'm going to put this on the side. Just look at these two signs, right? One is sine L1x, the other one is that. So for one, right? From between 0 to 1. Okay. So let me put up the number line here. The number line. Okay. So on this number line, there's a -1. There's a +1, sorry. There's a +1 and there's an e squared. Right here. So this is 1. So how the sign distributed? Between 0 to 1, ln x times -2 times ln x, that's negative times negative. That's going to be positive. Positive. Okay. Okay, so here we just still have a 0. Don't forget this, the domain. Okay, domain. Positive. At 1 is 0. Between 1 and e squared, positive times negative. So this is going to be negative. At e squared, that's going to be 0. And larger than e squared, that's going to be positive times positive. That's going to be positive. So now our solution is obvious. Our solution is obvious, right? So what are our solutions? Okay, you see the divide, right? You see the divide. The same idea, isn't it? Same idea. So now what is the solution to make that product, right? So solutions to what? To that inequality, which is this product, we want to be greater than or equal to 0. What would that be? Well, that's between 0 and 1, right? So your solution will be 0 less than or equals to 1. It can equals to 1, right? Or x is larger than or equals to e squared. That's how to solve this inequality. It's not trivial. All things must be considered. Okay, it's not trivial. All things have to be considered, but you can see a lot of the ideas and methods we used before are being used, right? And also the functions properties, right? The function, you really understand input, output, how you read the input, output, so on and so forth. Well, this inequality, I think is probably, probably as complicated as you can get, right? It takes a lot of time and energy to analyze it. Okay, so you may need to watch it over and over. And I think I'm going to end this lesson this time. And I have a couple more I'd like to go over with you. Since we have talked about solving equations, so solving inequality will just be so natural, right? So I'm going to make another lesson just to talk about a couple more examples from the homework to see how you analyze it, how to analyze it. If you can go through these multiple steps, right, and really understand the nature of the question, and you will realize a lot of the methods are very similar. It's just the rules of the functions are different. Okay, so without further ado, thank you for watching. Until next time.